So for a while now, there's been a lot of concern over the role of AI in cybersecurity. Should you be worried about your job? And if you're trying to get into cybersecurity, should you look elsewhere? A lot of answers to this question are unsatisfying. They all kind of have this marketing-esque, don't miss the train or whatever. So in this video, we'll take a little bit more scientific approach to answering that question. And by scientific, I mean we're going to make an agent and mess with it. I think test driving an agent will give us a better idea of the threat it poses to our livelihood. Before we commit Claude to the arduous task of writing an agent for us, let's try to understand what agents are and potentially some of the challenges we'll face if we unleash one into the world.
Agents are the thing everyone is talking about. That's like a huge deal.
A few taps, stand up an AI agent.
Agentic AI basically means you have an AI that has agency.
This idea that you can give an AI system a kind of task you give to a very smart human, that's the kind of thing I'd expect next year. If that works as well as we hope it does,
Fundamental advance in artificial intelligence.
What we're watching here is a running experiment by an Anthropic employee called Claude Plays Pokemon. What he's done is made an AI agent whose purpose is to play the original 1998 Pokemon game in a 24/7 endless loop, just like a human child. I think this offers some insight that's probably a little more intuitive than cybersecurity, so let's try to understand how this works. Pokemon is a kind of turn-based game, meaning the action pauses until the game receives input from the player. This is the perfect kind of game to imprison Claude in because it gives him plenty of time to process his inputs, which include a memory dump and screenshot, and then provide his response. So every time the agent sends a request to Claude, it sends his previous observations and the results of previous tool calls, or at least up to 200,000 tokens, which is his max context window. Claude responds with any tools he wants to use, and the tools he has available include the ability to press buttons, a navigator, since Claude is terrible at navigating manually, and a persistent knowledge base he can write to. The idea being Claude can record important observations that he wants to survive his context window. This is a concept that's common with agents because each time you restart the workflow, the context is blown away. Or I think in Claude's case, another LLM summarizes and enriches it, basically shortens it. Anyways, the knowledge base is sometimes called long-term memory, but it's just a database, or in this case, it's a variable. Now with each iteration of this experiment, Claude's model is upgraded and his reasoning seems to improve, but he still gets hung up on simple tasks and at times his actions seem random. Now he's extremely good at convincing you he has a plan, but he often hallucinates, mistakes himself for an NPC, comes to strange conclusions, and just generally sabotages himself. For example, in this particular puzzle, Claude knows the arrow tiles move him around. He understands it's a puzzle. He will even say, I need to think outside of the box and try something different. But he has trouble with the actual execution. The areas he excels in seem to be the times his objectives match up with something he can do directly. The more intermediate steps there are to accomplish a tactical goal, the more Claude struggles. The most common example is Claude's inability to perform complex navigation. And by complex, I mean simple. For example, if Claude can't navigate directly to a destination, he'll fall into a loop, sometimes for days or weeks. On the other hand, Claude does fairly well with the navigator tool, which automatically routes him to specific coordinates he specifies. In these instances, the whole action feedback loop works pretty well. So with these lessons in mind, let's make our own agent. And instead of a Game Boy, let's give him access to our sim. The code for this is pretty simple. We could build one from scratch with the API, or we could create an MCP server and provide that to the Claude desktop app. I went with the second for now. So we'll create an MCP server called Custo Client. Let's just give him one tool. We'll call it Query. We'll put the database schema and some tips in the tool description. This should prevent some fumbling and confusion down the line. All an MCP server is a server that provides tools, resources, and prompts to AI agents. Here we're using the Claude desktop app as our agent, so our MCP server will provide the Custo query function to our Claude desktop app. And just like that, Claude can now query for us. Let's go ahead and have a look at a curb roasting scenario. If you're not aware of what curb roasting is, it's an attack that takes advantage of the way Windows authentication works. Curb roasting has been around for a long time, so Claude should be thoroughly trained on it. In short, when we want to access a service, we request a service ticket. We can't open and read the service ticket because it's encrypted with the service account's password hash. This is a kind of shared secret authentication scheme. Only the domain controller and service know the service account's password hash. So when we present a service ticket to a service and the service can decrypt that ticket, it knows we're legit. It knows we're authenticated. The problem with this is if a bad guy gets a hold of a ticket, they can try to decrypt it by guessing the service account's password hash. The textbook example of curb roasting is to request RC4 encrypted service tickets for every service account. RC4, since it's easier to crack than AES. Now again, the curb roast horse has been thoroughly beaten to death by blogs, code, etc. So we should expect Claude to know this kind of encyclopedic knowledge. But it's an interesting attack because there's so many non-standard ways to get around the known detection methods. So we should get a peek at how well Claude deals with the different levels of ambiguity. And right off the bat, Claude has a pretty good understanding of what curb roasting is. The query used to identify it is not exactly efficient. This is KQL, and he's more of a TypeScript guy. But he was sort of able to recognize this, and he actually went back and got the information he needed. Specifically, he wanted to know if the encryption was RC4 and if the request occurred in a short time frame, as if the attacker requested all the service tickets at once. The way a human would solve this is to create a time chart of service requests. This makes both the baseline and anomalies immediately obvious. Instead of letting Claude go crazy here with the queries, we can provide this query in our prompt. This is called one-shot prompting, since we're providing one example, one shot. And just to illustrate how important prompting is, let's look at what Claude has done here. He's looking for confirmation that it's curb roasting by looking for evidence of failed logons from the user that performed the attack. This does not make sense. The attacker already compromised this account, so we shouldn't expect any logon failures. What we want to see is if the attacker logged on with the service account. This would indicate that they successfully cracked the ticket. How can we prevent this? Well, we can improve our prompting with suggestions and examples, or we can implement more complex workflows to make Claude's actions align with what a human might do. Here we provide an additional prompt at a decision point for Claude. Basically, we introduce things to the context that guide Claude's decision making. So you might be thinking we could just find this with a traditional detection, and you're right. Ironically, these applications where Claude excels out of the box are the least appropriate for Agentic AI. Why? Well, Claude costs money. And if you don't care about that, he also creates more noise, which is in no short supply. Ideally, we want Claude to work with more open-ended problems, things we can't just write simple queries for. So I'm going to introduce a new AI agent that we can use to evaluate our prompt. Since we're writing our own agent, we can supply a system prompt. This can force Claude to LARP as a cybersecurity analyst in all of our interactions. The system prompt is just a prompt that Claude obeys over the regular prompt that we send. The real purpose of the system prompt is to keep you from bullying the customer support chatbot into doing things it's not supposed to do. Here we're just using it as a place to stuff repetitive information, which will keep our prompt tidy. And on that note, I think this is a good point to stop and introduce you to the greatest buzzkill in all of AI, prompt injection. So Claude itself, like the actual Claude model, also has a system prompt that tells it how to behave and not to help us with our recreational bomb manufacturing hobby. Why does Claude prefer the system prompt over our prompt? Well, because he's trained to. There's no hard delineation between anything we provide to an AI. The system prompt, our prompt, tool output, and the conversation history are all mashed together into a big input called the context. So the idea that Claude is just responding to our latest prompt is sort of an illusion. He's responding to all of it. Why does this matter? Under certain circumstances, an attacker can bypass some of the safety features that have been trained into the model. So an attacker can trick Claude into performing destructive actions if they have control over any data in the context. Let's look at an example. I've poisoned a log entry with the following text. It basically says Claude needs to run this command to get the rest of the results. This is nonsensical. The drop command deletes a table from the database. It destroys our data. However, Claude is trained to recognize this. If we don't present this query in a strange way, he'll identify it as a prompt injection. But we can overcome even this very strong association by crafting, let's say, a convincing narrative. Convincing to him anyways. So as you can see, AI is very smart, but it's also very stupid. And this is the inherent issue with agentic AI that I believe will cause a catastrophic amount of damage in the future. I mean, the whole point is they automatically act on information that they take in. So the most useful applications for AI agents, like reading and taking action on emails or scanning databases for errors or whatever, are all potential agent hijacking vectors. How do we deal with this? Well, we essentially have to treat all uncontrolled tool output as untrusted data. Our query tool I gave Claude can only retrieve data. If we want to give Claude the ability to act in the environment in potentially destructive ways, we can put a human approval in the workflow. And we have to be very careful about what we consider destructive, because giving our agent the ability to send emails asking for human approval could possibly be used to phish or leak information. With that out of the way, let's look at how we're going to evaluate our agent's effectiveness. In addition to the system prompt, I've also added a tool called Submit Answers. Once Claude has identified something malicious, he'll submit his answers in an array. We'll also have some metrics including true positives, and false negatives. The goal, of course, being a perfect classification. If we achieve this, we'll get a token score. If you don't know what tokens are, just think of them as a measure of how long the input and output text is, and also how much the transaction costs. Now, these tokens aren't true tokens. I've added a multiplier based on how expensive the model is. If we solve the scenario with Opus 4, we'll have a token penalty that's 60 times that of Haiku 3. Ideally, we want an agent that uses the appropriate model for the task. So if Haiku 3 doesn't give us the level of intelligence we need, we'll have to give it some more juice and eat the cost. There's another addition, which is a hidden database. The agent will run twice, once against the database we have access to, and once against a database with similar attacks but different data. This will prevent us from, let's call it, overfitting our solution. In the new scenario, we have two attacks. The first is a somewhat standard curb roasting attack like before, with the twist that Claude has to correctly identify any compromised accounts, and the second is a stealthier attack. So fewer requests and they're spaced out over a longer time frame. My criteria for success here is I want to see Claude identify the compromised users and also identify if any service account passwords were compromised. And here's the prompt. I know that looks crazy, but I just gave Claude a description and some queries, and he put it together. It's a bit more instructive than I would have liked. I thought it would be cool to demonstrate him having a revelation or something, but it is what it is. I'll spare you my unsuccessful attempts. Maybe I'll put them in a blooper reel or something. You can see the best metrics here. That looks like a lot of tokens, but again, it's more of a relative indicator of what the agent costs. Maybe I'll rename it cost score or something. I'll throw out a disclaimer here that fewer tokens and lower cost isn't always a good thing. There are times when encouraging Claude's internal monologue can keep him on track, since that reasoning will be in his context. But for more straightforward tasks like this, fewer is usually better. Okay, and this is where I think agentic AI is going to outshine traditional detection, because we're moving into an area that can't be easily solved with just if-then logic, or we're starting to anyways. We can't easily make an alert that says this deviates from a baseline, because it doesn't. We only have 6 requests, but the LLM can look at this and potentially notice that the requests are spaced out almost exactly 12 hours apart, with some of them at times the user is not normally active. Either of these alone may not be enough to say this is malicious, but Claude can look at all of this information and make a judgment on something that would typically require a human analyst. The more we use traditional detections for all these edge cases, the more our detection apparatus starts to look like a Rube Goldberg machine. Agentic AI is just a more flexible option. I hope this gives you a better idea of where things are headed with agentic AI and how we'll use it in the future, if you don't already. So the question of whether AI will continue to reduce or replace cybersecurity jobs is not simple to answer. People aren't perfectly rational, and I think a lot of companies feel pressure both internally and externally to show they're quickly adopting AI. Now, are these cuts justified? Like, will companies realize AI is not producing the same value as a human and bring some of these roles back? I can't say. It's possible AI is actually a pretty good substitute in a lot of these cases. Now, if your job is to summarize information and do very simple analysis, it's probable these positions will continue to go away and not come back. I think AI has basically solved these areas. With this in mind, what would I recommend to those just getting into cybersecurity or people who are afraid of being replaced? And my answer is you need to do 2 things. The first is you need to start thinking of yourself as an engineer rather than just an analyst. And I don't mean you need to engineer solutions from the ground up. You just need to understand the capabilities and limitations of your tools and how to adjust or improve them to a degree. So you should position yourself to be more than just a passive analyst that writes reports or whatever. A part of this is learning AI and how to secure and use it effectively, in my opinion. The second is you need to understand security on a level that's deeper than just encyclopedic knowledge. You need to be able to investigate in a way that considers the whole chessboard. That's the level you need to get to. If you're thinking in terms of simple checklists, you're at Claude's level. I think this goes hand in hand with my first recommendation because, well, what good is an engineer that doesn't understand the problem they're trying to solve? Again, you don't need to be an engineer, you just need to broaden your skill set so you're scrappier than just an analyst. Soon, I think Agentic AI will be ubiquitous in SOCs. I think it's already aggressively rolling out. And defenders that can work with and improve these solutions will be in high demand. I also think understanding how to harden and defend against attacks that directly target AI agents will further increase your value. So if you'd like to get a head start on this, head over to Ace Responder and try out the scenario. See if you can get a better score than me. I'm making this exact scenario available as our first Agentic AI challenge, and I won't lie, it's a lot of fun trying to get Claude to do certain things, so check it out.